All right, so here we're going to introduce radicals. Basically, radicals is just a funny word for square roots. Um, so if you hear me use the word radical, we're basically talking about different types of roots, square roots. So our goal today is we're going to be working with different types of roots and whatnot. We're going to try this. I've not used this format to create videos in a while, so we're going to see how this goes. All right. So first thing we're looking at is finding a square root. Finding the square root of a number is the inverse. Let me grab my pen here. Okay. It is the inverse of squaring a number. Okay, so it's the opposite. I always think of square roots as Jeopardy. Okay, I'm giving you the answer. What's the question? There are there are two. I help if I can spell the word two roots for every perfect square. The principal or positive root and the negative root. And you'll see what I mean by that when we get into our examples. Okay. All right. So remember, when you take a square root, there's always two roots. There's the positive and the negative. What we have here, okay, right here, this little n, this is called the index, or basically the root being taken. So like this, I would read as the nth root. If you have a 3 there, it's the cube root. Okay. We don't normally put the 2 there, and I'll talk about that here in a little bit. The number underneath the root is called the radicand. And then the root symbol is called a radical. That's why it's called radicals. All right. It's totally radical, dude. Okay, so this little doodad right here is called a radical. Root symbol, same thing. All right. So those are the different parts. So let's get into here. So let's find the roots of the following number. So if we look at this one, the square root of 36. The square root of 36, well, 36 can be rewritten as 6 times 6. So that means the square root of 36 is going to be plus or minus 6. And that's how we write it. You write plus over minus. So it's positive or negative 6. Right? Next, square root of 64. Well, the square root of 64, we can write it as 8 times 8. So there's 2 8s. So we would write it as the positive or negative 8. Right? This next one's pretty tricky. Right? There's a negative sign in front of the root. So what this means is we only want the negative root. So if the negative sign is front, I only want -7. Okay? I don't want the +7. Okay? I only want the -7. And next, if we have the square root of -4, this cannot be done right now. If you've taken Algebra 2, which most of you have not, okay, you would know we have an I, we have an imaginary number. So right now, the square root of -4, it just cannot be done because we cannot have a negative radicand in our math. Next, the cube root, because there's a 3 right here. Okay, the index is a 3. So it's the cube root of 1. So basically what it's saying is we have 1 times 1 times 1. So the cube root of 1 is just 1. Anytime we have a cube root, it's only going to be the positive. Okay? Next, the cube root of 1/25. What this is saying is we have the cube root of 1 over the cube root of 125. And the cube root of 125 is 5 times 5 times 5. So the cube root of 125 is 1/5. And then this one, we want the negative cube root of 8. Well, the cube root of 8 is 2 times 2 times 2. And because we want the negative, the answer will only be -2. And this one, you may think, hey, look, there's a negative. We can't do this. But if the index or the root is an odd number, you can have a negative radicand. Okay. So if the root is an odd number, you can have a negative radicand. So this answer would be -3. Okay, so that's all our roots. Next, let's talk about approximating square roots. Let's choose a different color. Black's getting boring. All right. Approximating. A number that is not a perfect square can be approximated by using known roots or a calculator. Right? Calculator. Right, good old trusty dusty calculator. There is a square root button on your calculator. There's a cube root button as well. Okay, so if we look at square root of 3, so square root of 3, well, 3 is between 1 and 4. It's between 1 and 4. Well, we know the square root of 1 is 1, and we know the square root of 4 is 2. So we know the square root of 3 has got to be somewhere between 1 and 2. Right? But if you actually plug it into the calculator, you would get the square root of 3 is approximately, make sure you use your squiggle equal sign, 1.73. Okay. Right? So it's approximately 1.73. And that would be plus or minus. Okay. Square root of 34. 34 is between 25, that's a 3. 25 and 36, those are both perfect roots. Square root of 25 is 5. Square root of 36 is 6. So we know it's going to be roughly between 5 and 6. You plug it into the calculator, and you get approximately, again, that approximate symbol comes into play, 5.83. So plus or minus 5.83. And next, 70 is between 64 and 81. Right? And if you plug, so between 64 and 81, this is 8, this is 9. So we know it's going to be somewhere between 8 and 9. Plug it into the calculator, you're going to get approximately 8.37. So this is approximating our roots. Okay, so you got to look at the, because it may say, what's the approximate root, or it may just say simplify. We'll talk about that here in just a second. What if we want to find the square root of a variable? Right? So we got this wonderful variable. So to find the square root of a variable, you basically cut the exponent in half if it's an even number. We'll talk about the odd one here shortly. So basically, x squared, the answer is x. X to the 6th, the answer is, well, half of 6 is 3, x cubed. Now here, if we have a number and that, what this tells us to do is it tells us to take the square root of 16, and it tells us to take the square root of x to the 8th. Well, the square root of 16 is 4. Square root of x to the 8th is x to the 4th. And lastly, again, this one tells us to take the square root of x to the 6th, tells us to take the square root of y to the 12th, and then it also tells us to take the square root of z to the 8th. All right, half of 6 is 3, so this is x to the 3rd. Half of 12 is 6, and half of 8 is 4. So this is this answer right here. Simplifying square roots. Right, a square root is simplified when the radicand contains no perfect square factors. Perfect square factors. Hopefully my handwriting is legible here. So the product rule. So The product rule here, basically what this means is it means we're taking the nth root of A times the nth root of B, so we can split it up. And this one means we're taking the nth root of A over the nth root of B, so we can split these up. That's what these two mean, the quotient and product rule. All right, next. So if I was told to simplify, let's choose another color. Let's go with red. Red sounds fantastic. I love red. All right. So if we look at square root of 20, well, 20 is not a perfect root. Well, what are some factors of 20? Think about the factors. Remember how when we do A times C, or we're taking factors of C to give you B. Remember, we've been talking about a lot of these factors. Well, if we have something that's not a perfect root, let's look at see what factors are perfect root. Well, 20 can be rewritten as 4 times 5. So what we have is we have the square root of 4 times the square root of 5. So then we have the square root of 4 times the square root of 5. Well, square root of 4 is 2. Square root of 5 is square root of 5. So the answer, or the simplified version of square root of 20, is 2 root 5. If we look at 54, we can split 54 into 9 times 6. And that means we have the square root of 9 times the square root of 6. 9 is a perfect root. 6 is not and cannot be split, so we get 3 root 6. Square root of 35. Okay. Well, we think of all the factors of 35. Well, we have 7 and 5. And we take the square root. Well, none of those are perfect roots, so this is simplified. So the simplified version of the square root of 35 is just the square root of 35. Okay, you can't simplify that anymore because it has no factors that are a perfect root. Next, square root of 36 over the square root of 25. It's the quotient property. That's the square root of 36 over the square root of 25. Those are both perfect roots, so we get 6 over 5 as our answer. Next, square root of 40 over square root of 81. So we have square root of 40 over the square root of 81. Well, the square root of 81, that's 9. The square root of 40, that's not a perfect root. Well, let's think of some factors that are perfect roots. Well, we can rewrite square root of 40 as 4 times 10. Square root of 4 is 2, so 2 root 10. And the square root of 81 is 9. So we have 2 root 10 over 9. Now we're happy. Next, and this is that odd number exponent. Because the rules was with the exponent, you just cut it in half. Well, we can't do that with an odd number. We got to split it into factors that are perfect roots. So we got to take x to the 5th, and we're going to split it up into x to the 4th times x to the 1st. So y, that's x to the 1st. Well, we know the square root of x to the 4th, that's x squared. And we don't know the square root of x, so square root of x just stays under the radical. Next, we have 8 times y squared. We would split this up as 8 times y squared. Well, 8's not a perfect root, so we're going to split up 8 into 4 times 2 times y squared. All right, well, square root of 4 is 2. Square root of y squared is y. Those escaped. And 2 stays under the radical. The goal of numbers, they want to get out of the radical. Next, cube root of 54. Well, we can rewrite the cube root of 54 as 27 times 2. And the cube root of 27 is 3. So we have 3 cube root 2. $18 can be split into 9 and 2. Well, 9's not a perfect cube. It can be split into 3 and 6. Neither one of those are perfect cubes. So the cube root of 18 simplified is the cube root of 18. Cube root of 40 over 27. Okay. So we have cube root of 40 over the cube root 27. Well, the cube root of 27 is 3. Cube root of 40, we can split up 40 into 8 times 5. Cube root of 8 is 2. So we have 2 cube root 5 over 3. That's that answer here. So these are all the radicals. You got to read the directions. If it says simplify, you do what we just did. If it says approximate, you bust out the calculator. If it's a perfect root, you just do the perfect root. Okay? That's the big thing on these radicals. Hopefully that was a good lesson. Try your best. I'll hopefully be in tomorrow so that you guys can ask clarifying questions.